So this is the table given in your book of hypothesis testing in inferential statistics. So this is the table. I am going to explain this step by step. But before that, we are going to learn, and in this video we are also going to learn how hypothesis test can be conducted about a population mean and population proportion. But before that, what is hypothesis? So in simple words, hypothesis is a claim that we test. For example, if a study says 40% of the men in India snore, so this is a study based on a maybe survey or a generally accepted opinion. So this is null hypothesis. So if any researcher or any investigating agency wants to challenge this theory, they will have to get a sample from the population based upon the data they want to test and say so to challenge this theory they will come up with alternative hypothesis to challenge it. So the theory that 40% of men in India snore, that is an example of null hypothesis. And if any agency wants to challenge it on the basis of some data, so they will come up with alternative hypothesis. So H naught, null hypothesis is denoted by H naught or H0, and alternative hypothesis is denoted by H sub A or HA or H1 sometimes. So alternative hypothesis. So, if the agency comes up with the proof or evidence that this theory, null hypothesis, is wrong, then in that case we will reject null hypothesis. And if they do not come up with any evidence, then we will fail to reject null hypothesis. Because if we don't find any evidence against null hypothesis, then null hypothesis is assumed to be true. So we are not going to say accept null hypothesis. We are going to say that we fail to reject null hypothesis. This is the right language. So I am going to explain this to you, this table, with the help of some examples. For example, first column is of lower tail test. So what is lower tail test? Let's take an example. Suppose school board claims that students spend at least 5 hours a day on social media. That students spend at least 5 hours a day on social media. So H naught, yani null hypothesis, says that mu average is greater than or equal to 5, at least 5 hours a day. So 5 here is the hypothesized value of population mean. Okay, so this is an example of lower tail test. And what will be the alternate hypothesis? Suppose a teacher believes that this is not true, that null hypothesis is not true. So he will try to challenge this. He will try to come up with some samples. Suppose he samples 100 students and comes up with alternative hypothesis that this is not true, that students spend more than 5 hours a day on social media. That he samples 100 students and he came up with a theory that students spend 4 hours, say 4 hours a day on social media. But I'm not going to write it here that mu is equal to 4. We have to write alternative hypothesis as the opposite of null hypothesis. So it should be that mu is less than 5, because 4 hours a day is less than 5. So this will be the alternative hypothesis. So this is a case of lower tail test. Now what should be the next step? Next step should be to calculate the value of test statistic, that is Z. So Z is a standard score. So why can't we use X? Because X is the raw score and Z is Z score. In other words, we can say that Z score is simply the signed distance of every sample value from the mean in terms of standard deviation. If you know about normal standard distribution curve, you must have studied about that in chapter of probability. Then Z score is the distance of every sample value from the mean in terms of standard deviation. So on the basis of Z, it is easy to calculate where sample values rank with respect to other sample values. That's why we calculate Z. So what is the formula of Z? It is x bar minus mu naught divided by population standard deviation upon root of n. So what is x bar? X bar is sample mean. For example, in this case, if the teacher believes that all the students spend 4 hours a day on their social media accounts, then x bar is equal to 4. And what is mu naught? That is 5. That the school board claims that the students spend on their social media handles per day, more than 5 hours. So mu naught will be 5. So what is population standard deviation? We have already learned how to calculate standard deviation, population standard deviation, that is denoted by sigma, in our first video of inferential statistics. By the way, this value will be given in the question, sigma. So n is the sample size here. So this way we can calculate the value of z. So second row, test statistic, we have done that. Now next is rejection rule p-value approach. So before this, I want to talk about critical value approach, because after this it will be easy for you to understand p-value approach. So first we will do critical value approach. So what is the critical value approach? For this, first we have to know about the value of z, which is the test statistic here. So for example, z value that we have calculated on the basis of this formula, that is say minus 1.97, because we are talking about lower tail test, so that will be negative. So minus 1.97 here. So teacher was 95% confident that his theory is correct. So 95% is the confidence interval. We know that area under this curve is equal to 1 or 100%. So if 95% confidence means confidence coefficient is 0.95. So in case of lower tail test, if this area is 0.95, then what will be the value of this area? This area will be 0.05. 1 minus 0.95 is equal to 0.05. That means alpha. Value of alpha. This is also called area of rejection. Rejection area or area of rejection. So alpha will be 0.05. So this is also called level of significance alpha value. I will tell you later. So area of rejection is 0.05. Now Z test statistic, that value is minus 1.97. So now we have to calculate the value of Z alpha. What is Z alpha? Z alpha is Z 0.05. Now I am simply telling you this value. This is minus 1.645. We have already done how to calculate value, how to find Z value on the basis of alpha in our second video. But we will do it again while we are solving our problems in the later part of this video. But now simply just I'm telling you that this value is minus 1.645. So minus 1.645. Suppose at this level z is minus 1.645. So this area will be area of rejection. Now if RZ test statistic, I will call this Z data. So now if Z data falls in the rejection area, then we will reject null hypothesis. Let's see, minus 1.97, this will come on this side, left hand side. So obviously this falls under rejection area, or we can say that Z is less than equal to minus Z alpha, because this is less than, this value is less than minus 1.645. So we can say that on the basis of this proof we can reject null hypothesis, and this was our critical value approach. Reject null hypothesis if Z is less than or equal to minus Z alpha. If Z comes out to be negative, then Z alpha will also be negative. So simple funda is, if Z falls under rejection area, we will reject null hypothesis. Now rejection rule, p-value approach. What is the p-value approach and what is the p-value? First of all, p-value means, p here means probability, and what is p here means probability. Probability of getting more extreme values than ones observed in your data. For example, if I am going to take Z as minus 1.97 as per our example, minus 1.97, so this area will be p-value. Z alpha is Z 0.05 and its value was minus 1.645. This area is alpha and this area is p-value. Obviously, alpha area is greater than p-value area, where Z is equal to minus 1.645. From that point, alpha area will be defined, and we can clearly see that p-value area is less than equal to, this is less than alpha. So we will reject null hypothesis. So that is our p-value approach rejection rule, that if p-value is less than equal to alpha, that means we have to reject null hypothesis. Upper tail test is similar to lower tail test. There is only one difference. In upper tail test, value of Z will be positive and formula will be the same, and p-value approach rejection rule will be same. I am just discussing this critical value approach of upper tail test. For example, if our Z comes out to be positive, for example, Z is 2.5. Okay, this is the value of test statistic which we found out by applying this formula. So Z is 2.5. So this is positive. So Z alpha in this case value was 1.645. This will also be positive. So clearly this is an upper tail test because Z values are positive. So 1.645. So Z is equal to 1.645 comes here, and Z, and this area is rejection area, as we know, alpha area. This is the rejection area. Z test statistic was 2.5. So obviously this is on the right hand side. This falls in the rejection area, or we can say that Z is greater than or equal to Z alpha. So we will reject null hypothesis. Take another example. Suppose Z test statistic value is 1.5, or we can say Z data is equal to 1.5. So Z alpha was 1.645, so this was the rejection area, and 1.5 comes here where Z is equal to 1.5. So this area doesn't fall in the rejection area. So, or we can say कि Z is less than Z alpha. So that means we do not reject null hypothesis. So I think you must have understood by now that Z should not fall into the rejection area for null hypothesis to be true. If it falls under the rejection area, then we will reject null hypothesis. So this was the upper tail test. So what is two-tail test? In lower tail test and in upper tail test, we can see value of we can see less than, equal to, and greater than equal to signs. But in two-tail test, there is only one sign, equal to sign here. So if null hypothesis says that mean is equal to hypothesized value of population mean, then alternative hypothesis says that mean is sorry, not equal to hypothesized value of population mean. As we know, null hypothesis and alternative hypothesis are mathematically opposite to each other. Okay, so this is the two-tailed test. Only one sign here, equal to sign. So test statistic Z will be calculated in the same way. P-value approach will be same. There is only one difference. We will do that in our video of exercise 10.3. Okay, I'm telling you p-value will be doubled. We have already done that. Exercise 10.3, I have already uploaded that. So what will be the critical value approach? If this condition is true or this condition is true. Let's take an example, a simple example here. Example of two-tailed test. So what is two-tailed test? So there is no less than or more than sign in two-tailed test. Suppose teacher was 95% confidence, so confidence coefficient is 95.95. Okay, so this area will be 0.95. So this area, because this is a two-tailed test, so this area will be 0.95, 0.05 divided by 2, 0.025, and this area will also hold the same value, 0.025, or we can say alpha upon 2 and alpha upon 2, because what is the value of alpha? 1 minus confidence coefficient, or 1 minus 0.95, so 0.05. So this area will be alpha upon 2 and this area will also be alpha upon 2. So now, but Z value that we calculate on the basis of test statistic, that will come either positive or negative. Okay, suppose the value is positive. Suppose value is positive, then we have to compare this to alpha upon 2, this area, and if Z is positive, obviously this area is alpha upon 2. If Z is greater than or equal to Z alpha upon 2, then we will reject null hypothesis, and if Z value comes out to be negative, so this area will be alpha upon 2. So if Z is less than or equal to Z alpha upon 2, we will reject null hypothesis. Basic funda is Z should not fall in rejection area. If it falls in rejection area, same rule that we followed in one-tail test, then we will have to reject null hypothesis. I hope I made this whole concept clear. So I am going to solve one problem from ML Agarwal Applied Mathematics. Example number 1. Consider the following hypothesis test so that you can get better clarity of this concept. I am going to solve one problem. So null hypothesis says mu is less than equal to 25 and alternative hypothesis mu is greater than 25. So hypothesized value of population mean or average is 25. A sample of 40 provided a sample mean of 26.4. That means sample of 40, that means n is equal to 40. Sample mean of 26.4, that means x bar is equal to 26.4. Population standard deviation is 6. So now first step is to calculate the value of test statistic, that is z. So formula is this. So 26.4 minus 25 upon standard deviation is 6 upon 40. So it will be 1.4 into 40 because this value will be taken to the upper part of the fraction and divided by 6. So this value comes out to be positive 1.48. So z will be 1.48, that is positive. So as this is, there is less than greater than sign here, so this is one tail test and this is upper tail test because z is positive here. So now next step is to calculate the p value here. So what will be the p value here? As we already know, I already told you that I am calling this value as z data 1.48. So p value lies to the extreme part of the z data. So this will be the p value area. And how to calculate this value? Corresponding to 1.4 in the z value chart, positive value chart z, 1.4 corresponding to 1.4 and under column 0.08 we can find value, and that value is corresponding to 1.4 and 0.08. If we add 1.4 and 0.08, we get 1.48. That is the value of our z. So we get a value that is 0.9306. Wait, this is not the p value because as we know, as I told you in my previous videos, that in the chart values have been given corresponding to the left of z values. So this area is 0.9306, but we want this area, we want p value area which is to the right of z value here. If z is positive, p value area will be to the right, and if z is negative, then p value area will be to the left. So we want this area, so we already know that area under the curve is equal to -1 and p value area will be, if I subtract this area from 1, I will get my p value. So my p value will be 0.0694. Now comparing this value with alpha, p value is 0.0694. Alpha value in this example is that has been given is 0.01. Alpha value is 0.01. Now comparing these two values, 0.061. Obviously 0.0694 is greater. So p value is greater than alpha value. That means do not reject null hypothesis. Now critical value approach. For critical value approach, we will have to find out the value of z alpha. Test statistic value, we already know that. We will compare these two values. So what will be z alpha? Alpha is 0.01. So how to find this value? 0.01. So 0.01 means that we have to find under column number 0.01. Let's see. I have already told you this. We know that area under the curve. 0.01 area is this area, alpha area. So if alpha area is 0.01, then this area will be 1 minus 0.01, that means 0.99. So this area will be 0.99. As we know, in the Z value chart, values have been given corresponding to the left of Z value. So this area 0.99, we must look for this value 0.99 in this positive Z value chart. So 0.99, where is this value? This value is, if you can find out from your chart, this value is given corresponding to the row 2.3 and under column number 0.03. Value given is 0.9901, which is very close to 0.99 because this is 0.9900 and this is 0.9901. So this value of Z will be 2.3 plus 0.03. So this value will be 2.33. So Z alpha value is 2.33. Let's compare this value with the Z data, which is 1.48. So comparing this value, first of all 2.33. So 2.33 come here, and this is the rejection area. Now we just have to see whether our Z falls in the rejection area or not. Obviously doesn't fall. Z 1.48 will come here to the left of this Z alpha value. So it doesn't fall under the rejection area, or we can say that Z is less than Z alpha. That means do not reject null hypothesis. So this is our answer.